Hello everyone, Mindflare Retro back, and it is review time once again. I've been contacted by the GVDA technology company in Shenzhen, China, asking me if I would like to review one of their new smart digital multimeters. Of course, I agreed, and they were kind enough to send me this, the GD128 9999 count smart digital multimeter. It was sent to me at no cost for the purposes of this review, and as always, I will provide an honest and unbiased review. I don't do a lot of review videos, but I've always been curious about the design of this type of multimeter that has been appearing on the market over the past couple of years. If you browse around AliExpress and other China-based e-commerce sites, you will find these meters sold by different companies using different model numbers, but as far as I can tell, they are all the same. I'm not sure who actually designs and manufactures these smart meters, but reviewing one model's features and performance would be applicable to the other variants. These smart digital multimeters offer a lot of features for a reasonable price. Now, I am not an expert by any means, so my goal here today is to review this meter from the perspective of a home electronics hobbyist to see if it's suitable for that kind of task. That said, let's get this thing out of the box and have a look. Today we're going to be looking at and reviewing the GVDA Smart Digital Multimeter. This is the latest in the Smart Digital Multimeter in the GVDA lineup. This model being the GD128, a 9999 count digital multimeter. This meter arrived to me in its retail packaging. Quite nice packaging, I have to say. Lots of specs information on the back, full color photo on the front. So first impression is that it presents well. Now let's take a look inside and see what we have. I see a semi-hard case and this note on top in English on this side, thanking us for our purchase and looking for good reviews, and a thank you in what appears to be Russian on the other side. Now let's get into this case. Nice case, no writing on the outside. It is hard or semi-hard and is closed with a zipper. Aha, and here's the meter itself. It fits perfectly in its little case, and there's even a convenient pocket on this side for all the accessories, like the thermocouple, which looks to be of very decent quality as well. This multimeter can measure temperature. We will test that later. And also in our side pocket, we have our test leads. That do not want to come out of their plastic bag. Well, at first glance, they feel very run-of-the-mill. These are obviously PVC, not very flexible. The probes do come with Cat 3, Cat 4 protective end caps that are fitted on there quite tightly, which is nice to see. The probes claim to be rated for Cat 2 1000 volts, maximum 10 amps. I don't think I would push my luck that far with them. But for general hobbyist use, I'm sure they're more than fine. And of course, on the other hand, we have our standard sheathed banana jack connector. And taking another quick look at the probe cable insulation, it is definitely some form of PVC, not silicone, as it is not very flexible, but I'm sure it's fine for most people. Now let's look at the meter itself. It is in here quite securely, so I have to say A+ for the case. The design of the meter itself is a very simple form factor. The face has 5 rubber function buttons and a 3.5 inch or 9 centimeter color LCD screen. 4 banana jack sockets run along the bottom of the unit for plugging in your probes. These sockets are not color coded. On the back I see a flashlight, and on top a power button and NCV sensor. And the whole thing is protected in a rubber boot that fits quite nicely. Time to get the batteries in this thing and turn it on. I removed the rubber boot. In my case, this one's blue. It's also available in black and green when you're ordering. And this is the naked meter. Well, not quite naked. This is a very shiny and reflective surface. It looks like we have one screw at the back to get the cover off and put in the batteries. And how does this lift off? Ah, there we go. There's our slots for 3 AAA batteries. It is nice to see that a metal insert is used to hold the cover on the back. And now I have to find 3 AAA batteries. Batteries have been found. And it's alive. I decided to turn off a lot of my extra video lights and tilted the meter away from the camera to help reduce glare so it's easier for everyone to see. In general, the display is quite nice. It's bright, crisp, easy to read, and displays lots of information, even the ambient temperature. And here's a closer look at the function indicator section of the display. By default, the meter is in auto mode, cycling between voltage, resistance, and continuity. The meter is considered smart because it will trigger on one of these signals and display the measurement accordingly. Pressing the large red function button will take the meter out of auto or smart mode. And now by continuing to press the red function button, you can select which measurement mode you want to be in. As you press and cycle through the different measurement options, LED indicators inform you the correct sockets to plug your probes into. A handy reminder and a handy safety feature, especially when working with higher voltages or higher amperages. And speaking of safety features, there's a large red caution LED when you're working in amps measurement mode. There's even a handy flashlight built into the back of the unit. Just press this button on the side to turn the light on and off. Decent brightness too. Could come in handy. And over on this side we have the auto power off button. When the button's pressed, it toggles the auto power off feature on and off. When it's enabled, the unit will auto power off in 15 minutes. Now let's take a closer look at the leads that this meter comes with. They claim to be rated for a max of 10 amps, according to the embossing on the shaft. And the tips, with the protective cap off, are rated Cat 2, 1000 volts. And with the protective cap on, they were rated Cat 4, 600 volts. And as mentioned earlier, these leads have a standard 4mm sheathed banana jack connector. One minor complaint is that the leads plug into the bottom of the device, and the sockets are not color-coded, so you have to be mindful of using the correct sockets when plugging in your leads. If we take a moment to plug in the common lead, we need to look at the indicator on the face of the meter and line it up with the socket directly below on the bottom. And then do the same thing with the red lead. Line her up and plug her in. And they do plug in quite securely, although you will have to rotate them around to find a convenient position to leave them in. Now, because the leads protrude from the bottom, not to mention there's no tilt stand, you can't use this instrument upright on your bench. Or can you? 3D printing to the rescue. Cybernoid on cults3d.com has created a 3D printed stand for this meter and its other branded incarnations. I will leave a link in the description. Okay, let's start measuring stuff. The probes are plugged in, the meter is set to auto, and we will be using this. An AD584 voltage reference, and this 0.1% precision resistance and capacitance reference. All right, let's test some stuff. I have the meter set to auto, or its smart setting, so it should automatically detect voltages, resistances, and capacitance signals. We are starting with a 10 volt DC reference, and it is bang on for that one. Next is 2.5 volts. Oh, again, perfect. And now 5 volts DC, bang on again. And last but not least, 7.5 volts DC. Spot on. So far, so good. So far, the auto detection of DC voltages is pretty fast and pretty accurate. So now let's try resistance and capacitance measurements. These are 0.1% resistors. And we will start with 10 ohms. We're measuring 10 ohms spot on, and we also get a continuity buzzer. According to the manual, the buzzer will sound for any resistance measurement under 50 ohms. Moving on, let's test a 100 ohm resistor. Bang on again. Now 1K. Very good. 10K. Again, perfect. 100K. 100K it is. And just for fun, let's test a capacitor in smart mode. And through no fault of its own, the meter decides to test for resistance in smart mode. So obviously, if we want to measure capacitance, we have to get out of smart mode and manually select the capacitance measurement function. Let's start by measuring the 980 picofarad capacitor on this reference board. The measurement is pretty fast and being displayed in nanofarads, so 0.951 nanofarads is 951 picofarads, a 3% difference and within the tolerances of this meter. Now let's measure 10 nanofarads. Oh, look at that. Right on. And how about 100 nanofarads? 97.48, still within the 3% specs of this meter. Now let's test some diodes. I've got some general purpose 1N4004 diodes here. For this measurement, we have the meter set to its diode mode, and we will do a forward bias test. And we are seeing a 0.59 volt voltage drop across this diode, which is perfectly normal. And if we do a reverse bias measurement, we should be seeing nothing. And we do, so we know that the meter is measuring this known good diode correctly. Now, let's take a look at another kind of diode, LEDs. And like any other diode, we should be seeing a forward voltage drop, depending on the color of the LED. But also, it would be nice to see the LED light up. This is a nice feature of any meter because it gives us a visual indication that the LED is actually working. And in measuring this white LED, it lights up and we get a forward voltage measurement. Red LED, good. Blue LED, no problem. Green LED, all good. And yellow is good. Okay, now let's take a look at some frequency measurements. The meter is set to frequency and duty cycle mode, and the probes are attached to the function generator output of my oscilloscope. That is outputting a 10 Hz sine wave. That is being measured spot on. According to the manual, this meter can measure from 10 Hz to 10 megahertz. I will ramp up slowly to those higher frequencies. And here it's measuring 100 Hz, no problem. And here's 1 kilohertz looking good. 10 kilohertz, bang on. Now let's really crank it up. 1 megahertz. Look at that, dead on. And now up to 5 megahertz. We are seeing a little bit of error creeping in now, but still pretty impressive. I know that the manual says that 10 megahertz is the max frequency that this meter can read, but here I've jacked up the output of the function generator to its max, 20 megahertz sine wave, and this meter is measuring it spot on. Pretty cool. Okay, so I decided to set up a kind of real-world scenario here. Let's say I'm a retro computer repair hobbyist, and I want to test some voltages on this vintage Commodore 64C. I have the meter set to auto mode, and I will switch on the computer. You can see it is on by the red LED, and I will test one of the input rails, which should be 5 volts DC. It is taking the meter a while to settle on a voltage. There we go, 4.8 volts DC. That's about right, but again, the meter did take a while to get there. Let's test for the same voltage again at another location, 4.8 volts DC, but it found it a lot faster this time. Now let's try a quick temperature test. We need to swap out the probes for the K-type thermocouple probe. And just like the standard probes, we have to make sure that we're plugging the correct plug into the correct socket. Red into red, black into black. So red goes here. No, it does not. It goes here. Red lines up with red, and black goes into the common. And equally important, make sure that you're on the temperature measurement function. There we go. The meter's dual display comes in really handy for this type of measurement because the larger numbers on the bottom are displaying degrees Celsius and the smaller numbers above are displaying degrees Fahrenheit. If I take the thermocouple probe and pinch it between my fingers, we can see the temperature rising. And if I let go of the probe, the temperature should start to drop. It does, all the while displaying the temperature in Celsius and Fahrenheit simultaneously. Now here I've hobbled together a simplistic setup to measure small amperages. I've got a retrocomputer power supply outputting 5 volts over here, and a small electronic load on this side outputting 5 volts at 200 milliamps. The meter is hooked up, running in line with the 5 volts out of the power supply. I have it set to amperage measurement mode, and the leads, of course, are plugged into the correct amperage measurement sockets on this side, not this side. This side. And yes, you will be presented with visual and audio warnings if the probes are plugged into the wrong sockets. Let's turn on our electronic load. Again, the load is set to draw 200 milliamps. I'm not sure how accurate this electronic load is. So for all intents and hobby purposes, this meter appears to be measuring the amperage correctly. Let's turn up our load to 300 milliamps. The meter is measuring 298 milliamps. And if we go up a little higher to 400 milliamps, the meter is instantly measuring 398, 399 milliamps. Unfortunately, I can't go any higher on this electronic load because I have it running on an insufficient power supply, hence the beeping. Now, it would be nice if I had one of those new budget process calibrators off of AliExpress. That way we could throw all kinds of decent reference signals at this meter. Good for testing, but I don't have one. Maybe in the future. I think we've done enough basic testing, and now it's time to take this thing apart and have a look inside. For starters, we need to get this rubber boot off. There we go. That is definitely not falling off on its own. There's just one screw to get the back off. And 2 other screws to take apart the case. How did this back lift off again? Right from the top. Revealing the batteries, but no fuses yet. I guess we have to take these 2 screws out to get into the back and the fuses. We shall see. Great. Now, how does this come apart? Looks like a small pry tool is required. No other screws, correct? There we go. Actually, now there we go. And there's the 2 fuses. Well, not the easiest meter to get into if you have to change the fuses. Anyway, let's have a look around. At first glance, it doesn't appear to be an overwhelmingly complicated design. I don't see a lot of input protection. That said, I am definitely not a multimeter design expert, although I have done my own research and can confidently say that a whole bunch of SMD resistors and a tiny little PTC are likely not enough protection for either the user or the device itself. On that note, if you want an expert explanation of multimeter input protection, I would highly recommend watching Dave Jones's EEV blog, video number 373, where he does a deep dive on that subject. Here's a closer look at the input side circuitry. Looking at the voltage input side, we are seeing the bare minimum of input protection. Again, I'm not an expert or professional on multimeter design, but from what I do know, most often you will see a PTC in line with a 10 mega ohm high wattage resistor. And typically that resistor will be a high wattage wire wound resistor. What we're seeing here is a PTC in series with three 3.3 mega ohm higher wattage SMD resistors. In series, they do add up to 10 mega ohms, but how do the protection characteristics differ from a wire wound resistor? I don't know. Now, working in conjunction with this initial PTC protection scheme, commercial grade meters will also include MOVs, or metal oxide varistors. These absorb pulse energy from transient voltages and impulses. There are no MOVs for additional transient voltage protection in this meter. Now moving on to the milliamps and amps measurement side, we see a lot more SMD resistors. Multimeters calculate current by measuring a voltage drop across a known resistance. Plug those two values into Ohm's law and you have a measurement for amperage. I suppose on the milliamp side, an array of small SMD resistors is good enough to calculate current. However, measuring higher currents, up to 10 amps on this meter, I would expect to see the standard thick gauge wire shunt as opposed to another array of small SMD resistors. The meter and potentially your hand are protected by these two unbranded fuses. Personally, for me and my hobby electronics, I don't have a real need to measure high amperages. However, if you do and you're satisfied with the safety of this meter, I would recommend not to measure high amperages for a long time, and I would highly consider replacing the existing fuses with proper name brand ones from a reputable source. The internal construction of the meter consists of two PCBs, a smaller one on the input side and a larger one on the logic side. The probe socket connections are basic crimped metal, but I did find that the probe plugs did connect quite securely. And finally, let's take a look at the logic side of things. This is a latching signal relay handling the switching between different modes and measurement types. And over on this side, we have a 20-bit analog to digital converter. And smack in the middle, we have the chip that puts the smart in this smart meter. The SD7502 dedicated multimeter IC. This little system on chip performs all of the measurement functions of this multimeter. And the other little QFP over here is the TM1729. This is the LCD display driver. And that is a quick overview of all the major ICs running the show on the GD128 Smart Digital Multimeter. Now, something I did forget to do is the ever popular lead tapping continuity test. Every other multimeter reviewer out there seems to do this test, so we'll try it too. Oh, surprisingly not very sensitive. I suppose the leads could be dirty from all my tinkering and handling doing this video, but not that dirty. Out of curiosity, let's try this again with a pair of high-quality Probe Master probes. Wow, that is a noticeable improvement. I guess it's another thing to consider. If you're not satisfied with the continuity measurement speed of the probes that come with this meter, you may want to invest in a higher quality pair of probes. But if you're a hobbyist and doing high-speed continuity measurements isn't a mission-critical thing, then I'm sure you'll be fine using the probes that come with the meter. Oh, and speaking of things that come with the meter, I forgot to talk about the user manual. It is roughly the size of a playing card and consists of 42 English-only pages of instructions on how to use this meter. If you're interested in browsing through it, I will post a link to a PDF download in the description below. Thus endeth my review of the GVDA GD128 Smart Digital Multimeter. Again, my review and opinion is from the perspective as to whether this meter is suitable for the electronics hobbyist. My list of pros include the form factor. It is very compact and light. The LCD is clear and bright, and all information is very easy to read. Of course, with the pros come the cons. And looking at the big picture, my negatives for the GD128 aren't really all that negative, assuming you're using this meter as an electronics hobbyist. No one's buying this meter for commercial or industrial use, so the lack of input protection for someone who's at home working on hobbyist projects on their bench is not a big deal at all. The fact that the input sockets are not color-coded is not a huge deal. It's more of a nuisance than anything else. Just be mindful to connect the correct probe into the correct socket. And if you make a mistake, the meter's going to shout at you with beeping and flashing lights. Because there's no stand, the meter is going to have to sit flat on your bench. If that's an inconvenience for you, then, as we saw, a suitable stand can be 3D printed. And lastly, the probes are of middle-of-the-road quality. That said, most of the measurements you take will probably not be affected. But if you need a faster response for continuity testing, you can always upgrade to a higher quality name brand set of probes. And that's it for my review of the GD128 Smart Digital Multimeter. My thanks to GVDA for sending this meter to me free of charge for review. If you are interested in purchasing the GD128, I will include a no-cost-to-you affiliate link in the description that will take you directly to the GVDA store on AliExpress. As always, leave questions and comments below. Thanks for watching, and a very special thanks to all of my Patreon supporters, whose names are appearing on the screen now. Patreon not your thing, but you still want to support this channel? No problem. Try a super thanks. Click it below, right beside the like button. I hope you enjoyed this review. Thanks for your time, and I will see you again soon.